and welcome to The Huddle, Conversations with the Diabetes Care Team. In each episode, we speak with guests from across the diabetes care space to bring you perspectives, issues, and updates that elevate your role, inform your practice, and ignite your passion. I'm Kirsten Yale, the Research Manager for AADE. The following is an interview by Crystal Broge, former Chief Technology and Innovation Officer with AADE, and Dr. Mick Davidson of Wentworth Health Partners in Endocrinology and Diabetes.
Hi, I'm Crystal Broge. One of the things that drew me into this space was my sister, who's type 1 and is always wishing for a new pancreas. I often hear about things like closed loop, DIY, and even artificial pancreas. So I wanted to get some answers about this area, and I found the perfect person to tell us about it. With me today is Dr. Mick Davidson, who works for Wentworth Health Partners, an endocrinology and diabetes consulting firm in Dover, New Hampshire. Dr. Davidson not only helps persons with diabetes, but he himself is a person with diabetes who has had some interesting experience with the advancement of technology over the years. Welcome, Dr. Davidson.
Thank you so much, Crystal. It's my pleasure to be here.
Is it okay if I call you Mick?
Oh, please do. That's what I like to go by.
Sounds good. So Mick, today I wanted to focus on all of the terms around artificial pancreas options, where they started and where they are now. So maybe we can start with some of the terms that I hear: artificial pancreas, automated insulin delivery, closed loop, hybrid closed loop. Can you define some of these for me?
Sure. Well, I think the big umbrella term for all of them is really automated insulin delivery. And that means that a device, whether it's a pump or some other device, is determining how much insulin is needed at any given time based on what's been given previously and what the blood sugar is at that moment and where it's been and where it's predicted to go, and delivers insulin appropriately in a very uniform and a very precise way. So an artificial pancreas is a type of automated insulin delivery system, and it's a commonly used phrase. Many people like to get away from the term artificial pancreas because the public or people with diabetes may consider that to be like an artificial heart, where it's actually something that is being surgically implanted. And these devices are really much like what we have right now with insulin pumps and continuous glucose monitors, but being used in conjunction with each other so that the data is being used in the most efficient way and best way to help the person using it to control their blood sugars. A hybrid closed loop is a device that requires the user to continue to count carbohydrates and enter their mealtime doses as they've been doing all along. But in the background, it's adjusting the infusion of insulin to assist the patient to stay within a target range, where a full closed loop does not require the user to announce that they're having meals or to enter any carb amounts. And it essentially sees that the blood sugar is moving from food and adjusts on its own.
So what is automated insulin delivery and what should it do?
Automated insulin delivery is using a continuous glucose monitor and an insulin delivery device such as a pump to allow the person with diabetes to not have to make minute-to-minute calculations to keep themselves within range. And certainly the time when you would view this as being most beneficial is when a person is sleeping, when they can't be as attentive to their blood sugars, and it will adjust in the background and allow the person to confidently sleep through the night and wake up with their blood sugar in target. The same thing happens throughout the day, and essentially it's a device that takes away a lot of the minute-to-minute responsibility and calculations that every one of us with type 1 diabetes has to do throughout the day. I feel that every automated insulin delivery system, to really be one that helps the user, should do three things. And those are, number one, to increase the time in range. Number two, to reduce the frequency and severity of low blood sugars, as well as high blood sugars. And number three, and most importantly, improve the quality of life of the person who is using it.
So what are the parts of this type of a device that someone would have to have in order for it to work?
Well, every automated insulin delivery system needs to be provided with continuous blood glucose data. So a continuous glucose monitor is really a fundamental and mandatory part of the system. For most of the systems that are being developed, they use an insulin pump so that the insulin delivery can be adjusted in real time and in very precise increments, as well as to be used for bolusing at meal times. But there are some systems that are being developed using what are referred to as smart pens, which are the standard insulin pens that we're using for long-acting and short-acting insulin, combined with some sort of controller app, like on a smartphone, that would prompt the person using the device to administer insulin appropriately.
Great. That really helps me understand that. You've had some personal experience with the evolution of these devices, including being part of an early trial. Can you share some of the things that you've seen and how it's evolved over the years?
Absolutely. The first time that I used a continuous glucose monitor was way back in 2006, and it was one of the early versions of the Dexcom system. It was certainly not as accurate as the devices we have now. It required calibration, but certainly it was a revelation to be able to see blood sugar in real time. Once we had these continuous glucose monitors that were able to provide continuous data to a device, you started to see the development of the first artificial pancreas devices in around 2013, when the Medtronic 530G, which did a threshold suspend, meaning that if the blood sugar dropped below a certain target, it actually stopped the infusion of the pump. And they showed that that reduced the severity and duration of time that people had low blood sugars when they were using it. So that was the first device. Around the same time, I was able to participate in a trial that was conducted at Massachusetts General Hospital of a dual hormone artificial pancreas. And they actually call their system a bionic pancreas, again, to differentiate between something that would be surgically implanted. But this device has insulin as well as glucagon, the counteracting hormone of insulin, and it was giving both in real time to maintain blood sugars within a normal range. I was participated in the trial for 5 days, where I lived in a hotel room in Boston and was able to just enjoy the city and eat what I wanted to eat and test this device. And it worked really, really well for me. And it gave me a huge excitement about what was to come.
Yeah, that sounds really interesting. And that was already a while ago. So can you give us some information about commercial devices that are on the market today or that soon will be?
So since then, you've seen evolution of the Medtronic system with their 630G that did actually a predictive suspend. So you didn't actually have to hit that low target for it to stop delivery. And that actually reduced not just the severity and length of low blood sugars, but actually the frequency of them. And then about a year ago, we had the first hybrid closed loop that was commercially available, was released, and that was the 670G, and many people have benefited from that. You have several other companies that have investigational devices that we hope are FDA approved in the near future. I think that the closest one, from what I'm hearing, is the Tandem Control IQ system. Their algorithm, the mathematical formula that helps determine insulin delivery, was developed at the University of Virginia. And then it was actually acquired by Dexcom and then licensed to Tandem. So that system will include the Dexcom G6, the Tandem t:slim X2 insulin pump, and then a software upgrade that will be published once the FDA approves the system. Additionally, there's the Omnipod Horizon system. I'm hearing mid to late 2020. And then the system that I tested is now referred to as the iLet from a company called Beta Bionics. And they'll be releasing an insulin-only version prior to coming out with the dual hormone, which will also have glucagon. The insulin-only version is expected to come within the next year or so.
Super exciting stuff. And what a difference from a couple of years ago to now have that ability.
Absolutely.
So I hear about this other stuff, the DIY. What do our educators need to know about that space?
Well, it's interesting that you ask about DIY closed loop delivery. After participating in that trial, it was really somewhat of a letdown to go back to just managing my diabetes as I had always done. And around 2016, one of my friends who was very involved in the diabetes technology space, made me aware of the DIY community of people who are developing their own systems that are not FDA approved for closed loop insulin delivery. It originated around 2014-15. There was a couple, Dana Lewis and Scott Librand in Seattle, who had sort of the same feeling of this is not good enough and we need something better. And so they wrote a software program to automate the delivery of insulin through a Medtronic pump that had a particular security vulnerability that allowed you to, if you knew the right radio frequency, to send it instructions. And so they wrote a series of mathematical equations that would tell the pump to either lower or raise its basal rate in response to blood glucose in real time. And that has evolved over time with really beautiful evolution of the devices. The one I began using a DIY system called Loop in 2016. I just had my 3-year anniversary of starting to use that system on November 18th. And the advantage of Loop is that with a small device that translates the Bluetooth signal from an app that you build on your iPhone, it translates it into radio frequency that Medtronic pump with the particular software vulnerability can understand. And it also pulls the data from the pump back to the phone. And so it actually creates a hybrid closed loop using an iPhone, this translator device called a Riley Link, and a Medtronic pump. And after that, actually about 8 months ago or so, the people who do the software development for this system, which is all open source and done for the goodwill of the diabetes community at large, figure out a way to use the Omnipod radio frequency pods to do the same thing. And so there are many, many people who are using these do-it-yourself systems. The mantra of the community is we are not waiting, meaning that we're not waiting around for commercial devices to be available when we may be able to build systems that work just as well or better in right now.
So DIY is building your own device if you're smart enough to write it, all that algorithm and do that stuff. I write computer software, and it's I can't even imagine the level of detail you have to do. But do you see this continuing?
I just want to be clear that I didn't write any of the software, and it's actually a fairly doable process. It's a matter of downloading the software that's been written by these people who have real expertise in programming. You do have to build the app on your iPhone, but it's actually a fairly straightforward process. And there's a tremendous amount of support from the community through online means, as well as through some live meetups where people will actually build their systems as a group. And so it does not take a computer programmer or someone who has experience with coding to be able to build one of these systems. In terms of what's next for DIY systems, well, we do have a lot of commercial systems that will fill the same void that are coming to market. But there are people who I think will find that Loop or the open APS system may be a better fit for them. I feel strongly that it's not one size fits all in terms of algorithm performance, and that we can get into the kind of discussion of pick your pump, pick your sensor, pick your algorithm that we're hoping that will come in the future through FDA approved devices. A company called Tidepool, which is fairly well known in the diabetes community as a way to download meters and pumps and report data, is actually building an FDA approved version of the Loop app. They've been in contact with the FDA to identify what they'll need to show in terms of the safety and effectiveness of this app. And it will appear once approved in the Apple App Store and will be compatible at this point with the Omnipod Bluetooth pods called the Dash system. But I would expect that there are, with other Bluetooth enabled pumps, you may see it as an option for systems other than the Omnipod. So I think there still is life for the DIY community for the next several years and likely beyond that, because the people who developed this have real insight into what individuals with diabetes need on a day-to-day basis, what the struggles are, and that may be lacking sometimes from commercial options that are available.
Can you talk a little bit about how to tell if someone is ready for this type of system?
Well, it is DIY, so everyone must do it themselves. There's no one who's going to build it for you. And so you have to be ready to take on the responsibility of doing the building and troubleshooting of any errors that might come up. There are certainly certain hardware requirements that are necessary. For example, with Loop, you need to have a Macintosh computer, an iPhone, the communication device that I referenced earlier called the Riley Link, and then either an Omnipod Eros, the radio frequency Omnipod, or a Medtronic pump that has a certain software number that you can identify under the utilities menu. Identifying which individual is best for using this sort of system. I think there are many people with type 1 diabetes who could be excellent candidates, but don't know it because they aren't aware of the system being out there. That person would be someone who is really engaged in diabetes self-management. They are an experienced user of a pump already, so they aren't starting from scratch with learning how to use the pump and learning to use a closed loop insulin delivery system at the same time. And someone who's willing to be, I think it's important to be upfront with your medical provider and let them help you to get the most out of the system.
And that's one place where our educators excel, is being able to help people with looking at that data, figuring out how that works. But is there a particular way, Mick, that you think of that is a good way to onboard someone onto a closed loop system to make them successful? And how would you recommend educators help in that process?
I think the diabetes educator can have a huge and tremendously beneficial role in an individual having success with either a DIY closed loop system or one of the commercial systems. The first step that I think that diabetes educators can really help with is having individuals formally test their basal rates. That's not something that we tend to do. It's sort of, when I remember when I first started using a pump about 20 years ago, that was something that was recommended to be done approximately every 6 months. And I find that it's an overlooked aspect of pump management, is really assessing whether those basal rates are accurate and effective. Many people have basal rates that were set 10 years ago and they've never modified them. I always tell people that our insulin settings are not written in stone, they're written in sand. And the wind that blows that sand around is exercise, it's aging, it's changes in your diet. There are so many factors that can affect your insulin requirements. And so it's stepping back and assessing first the basal rates, and then, although more difficult but doable, assessing your insulin sensitivity and your insulin to carbohydrate ratios, because the Loop system, as well as several other of the commercial systems, do use the baseline settings of the pump to make decisions off of. And so therefore, the closer that your baseline settings are to being appropriate, the better the device is going to work.
That is really good advice. What about a backup plan? I know you and I talked about that earlier. Backup plan for what if it fails?
Absolutely. That's an excellent point. Those Medtronic pumps that have that security flaw, they were only manufactured for a couple of years. So there's a limited number of them out there. When I first learned about this system, I went to my closet, to my pump museum, where I have all of my old pumps that I'm a hoarder, so I tend to keep all of my old devices. And I just happened to have one of them. Subsequently, I found a way to obtain a backup device. So I do have a backup Medtronic pump that I could use. But certainly, I think everyone should have backup basal insulin that they can fall back on if their pump was to fail. You really can't get by, if you're a pumper, you can't get by with just the rapid acting insulin. You need to have some form of basal insulin. And so having prescription on file at a 24-hour pharmacy for a long-acting insulin, or having a pen in your fridge that you can go to if you do have a pump failure is totally appropriate. Now, on the other hand, if let's say you're using Loop and the app fails, well, what you have at that point is an insulin pump and a continuous glucose monitor. And that's currently the standard of care. So making sure that people are confident with using their pump and sensor appropriately, that they know how to count carbs well. There is a certain amount of less precision that I think people are able to get away with closed loop systems, because it is helping you a lot in the background. And certainly if you go back to manual dosing, you need to be accurate with that. So making sure that everyone has all of the standard backup supplies that you would have for any pumper or any pump user. Additionally, none of this pumps and the sensors are FDA approved, but using them in this method is not FDA approved. So the individual needs to understand that there is some risk involved. For my personal experience, these last 3 years have been safer and have let me achieve a level of control that I couldn't have imagined prior to going to a closed loop system.
Today was all about closing the loop on artificial pancreas options, both DIY and commercially available ones, and ones that are going to be available in the future. Mick, what can our listeners do now to continue their learning in this space?
Well, I think there are a lot of great resources for people to learn about what the benefits are and the history of closing the loop and automated insulin delivery. If they're interested in learning about any of the commercial devices, you can look on the websites of those device manufacturers like Medtronic, Tandem, or Omnipod. Many of them have published their clinical trials examining their devices. For example, the iLet that I participated in their clinical trial, they have a site called Beta Bionics. That's the company that's manufacturing the device, and they have all their publications and really an explanation of the device. If you're interested in the DIY community, openaps.org, the Facebook group Looped, and as well as the Loop docs are all online and are great resources. I also love the website Diatribe. I use that as a resource for myself and for the patients that I see, and they have a large section on the history and the present and the future of automated insulin delivery. If someone is interested in participating in a clinical trial for the commercial devices that are coming out in the future, going to clinicaltrials.gov and then searching for artificial pancreas or automated insulin delivery is a great resource to find what's available close by.
That's awesome. And then, of course, listeners, you all know that you can go to danatech.org and find out all about pumps and CGMs and closed loop systems there under our product section. I'd like to thank my guest today, Dr. Mick Davidson, for being part of our program. And for those of you that are looking for those resources, they'll be published on the podcast page. Mick, thanks so much for being with me today.
Thank you so much for having me on. It was really a pleasure, and I hope that this is helpful for everyone who wants to learn about automated insulin delivery. I think it should be within a couple of years, not something that seems futuristic, but is really the standard of care to come.
I agree. Thanks so much.
Oh, you're welcome. Thank you.
Thank you for listening to this week's episode of The Huddle, Conversations with the Diabetes Care Team. Today we closed the loop on the artificial pancreas options. We learned about automated insulin delivery, different types of systems available both commercially and in the do-it-yourself space, and some tips on how to onboard to these systems. To access these resources and notes from today's discussion, visit diabeteseducator.org/podcast. The information in this podcast is for informational purposes only and may not be appropriate or applicable for your individual circumstances. The podcast does not provide medical or professional advice and is not a substitute for consultation with a healthcare professional. Please consult your healthcare professional for any medical questions.